Fine. Sorry for that, a small technical this thing. I think it's live now. Fine. So as we know, we are into the EMF full comprehensive course, completed static field theory. We are supposed to enter into time varying field theory. The first topic of that is Faraday's law, lecture number 34. Before we start, let me introduce myself. I am Chaitanya Reddy, secured AR 1931, works as a motivation speaker, expert in EMFT, communications, advanced communications, microwave engineering, antennas and digital circuits. We all have a YouTube channel named GATE Conqueror. So you are into this particular GATE Conqueror channel, and this is the Telegram channel for the same GATE Conqueror channel. You can access all the GATE Conqueror faculty here on this Telegram channel. Take a screenshot of this, dear. Anil, good morning, dear. Unacademy provides you two paid platforms. One is Plus subscription. The other is Iconic subscription. In Plus subscription, you got to have FaceTime of legendary faculties in the form of live classes, weekly test, structured courses, unlimited access, rank improvement batches, and crash courses. And in Iconic subscription, you get a personal coach for one-on-one guidance, dedicated doubt clearing educators, customized study planner, study booster sessions or workshops, personalized test analysis, and specialized notes and practice sets. All this in Iconic subscription. Iconic subscription includes all the features of Plus subscription, and additionally you get these extra features. If you're going for a Plus subscription or an Iconic subscription, you can go for a no-cost EMI. But the total cost will be divided by number of months. For suppose you are going for a Plus subscription of 12 months, then what you need to pay is 2,704, because the total cost will be divided by number of months. This is after using my code GCR10. You can use the code for either Plus subscription or Iconic subscription, and you can avail no cost EMI for both the cases. So we are into the full comprehensive course on EMF, completed static field theory, derived all the Maxwell equations, and in this particular session we'll start up with time varying Maxwell equations. In the previous class we completed continuity equation, a fast revision of that, because continuity equation is a key equation that interrelates Maxwell equations for static fields and Maxwell equations for time varying fields. So let us see, or let us revise this concept once before we move in. Let us see the concepts of current, current density, the relation, continuity equation, and Ohm's law. As we know, current can be defined as rate of flow of charge is given by dq by dt. And this current, yes, Chandani, good morning, dear. And this current is related to current density as current per unit surface area, given in ampere per meter square. If you consider small surface area ds, the current is di over there, then di is equal to j into ds. This is called scalar notation. and in vector notation di is j dot ds. From this I is surface integral of j dot ds. If this current is enclosed by an open surface, or I is closed surface integral of j dot ds. If it is enclosed by a closed surface, that's about current and current density. Any doubts here, dear? Any doubts here? You can ask, dear. Yes, Anil, Chandni, anyone? So we are done with current and current density. And as you know, continuity equation is from the concept of conservative property of charge. According to conservative property of charge, the rate of decrease of charge within a closed volume is equal to net outgoing current. In the previous class also I had given you an example of cell phone, the charge that is stored in the battery of the cell phone, and how it is related to conservative property of charge, which is a natural phenomena. Yes, Rasul. So minus dq in by dt is equal to I out. The charge enclosed in the volume is given by minus d by dt. Q is volume integral of rho v dv. I out is closed surface integral of j dot ds. Because in LHS we have volume. Therefore, closed surface integral of j dot ds is volume integral of minus dou rho v by dou t of dv. Applying divergence theorem, closed surface integral of j dot ds is volume integral of del dot j dv is volume integral of minus dou rho v by dou t of dv. Removing the volume integral, continuity equation is del dot j is equal to minus dou rho v by dou t. This continuity equation is from conservative property of charge and which cannot be wrong. It is always true. Why I am trying to stress on this point that it cannot be wrong, because this is the main point on which Maxwell has contributed for time varying fields. So this is the main link you need to understand. So from continuity equations, del dot j is equal to minus dou rho v by dou t. And how continuity equation is related to Ohm's law? Anyone? How this continuity equation is related to Ohm's law? Yes, dear. Now if you consider continuity equation del dot j is equal to minus dou rho v by dou t. This is continuity equation. If you consider that the current is single direction, let the current is flowing in the x direction, then generally if you take current density, J is in Cartesian coordinate system Jx Ax plus Jy Ay plus Jz Az. But I am considering that the current is only in x direction. J is Jx Ax. You know del is dou by dou x of ax plus dou by dou y of ay plus dou by dou z of az. If you do the dot product now, these are gone. Ax dot ax is 1. Del dot j is dou jx by dou x is minus dou rho v by dou t. From this, you can write dou jx is equal to minus dou rho v of dou x by dou t. What is dou x by dou t here? Velocity given by drift velocity. Dou jx is minus dou rho v dou x by dou t is vd, drift velocity. Drift velocity in terms of electric field is given by mu into E, where mu is the mobility. Where mu is the mobility, where mu is mobility given by Vd by E. Meter per second, volt per meter, meter square per volt second, unit of mobility. So replacing minus dou rho v, Vd is mu E. Removing the derivative, and as the amount of current that is flowing is always positive, neglecting the negative sign for practical considerations, what do you get? Jx is equal to rho v mu into E. But you know rho v into mu is sigma conductivity. Substituting from this you get J is equal to sigma E. What is this? Conduction current density. This is called as, this conduction current density, this is called as Ohm's law for field theory. Can you tell me why it is called Ohm's law? Why it is called Ohm's law, dear? If you see this is current density, current per unit surface area, sigma V is volt per meter, sigma conductivity is 1 by resistivity, I by A is equal to 1 by rho, potential V by L, V by I is equal to rho L by A. You know rho L by A is nothing but resistance, implies V by I is equal to R, V is equal to IR. What you got? You got Ohm's law. From which equation? From this equation. This is Ohm's law for circuit theory. These both are equivalent. That's why this is called Ohm's law for field theory. Is that clear? So that's about current density, continuity equation and its relation with Ohm's law. We are done with the Maxwell equations because we are going to change these Maxwell equations now. Let me summarize what are the Maxwell equations we have derived. Derived 4 Maxwell equations. This is equation number integral form, differential form, and the reason, or you mean source for this equation. Okay. Yes. Yes, Srikanth. Equation number 1. Closed surface integral of d dot ds is equal to volume integral of rho v dv. Differential form del dot d is equal to rho v. Reason, Gauss law for electric fields. Second equation, closed loop integral of E dot dl is equal to 0. Differential form del cross E is equal to 0. Conservative property of electrostatic field. Electrostatic field is conservative. It is the electric field moves in a straight line. Its rotation is 0. Third equation, closed loop integral of h dot dl is equal to surface integral of j dot ds. Del cross h is equal to j. Ampere's law. Fourth equation, closed surface integral of B dot ds is 0. Differential form del dot B is 0. Source, non-existence of magnetic monopole. Non-existence of magnetic monopole, also called as Gauss law for magnetic fields. Why I am trying to summarize this is, now we are entering into time varying fields. We will derive Maxwell equations for time varying fields also. So how is Maxwell equations for time varying fields completely different from the static fields? No. Only small changes will be there. What are those small changes? The first point you need to remember is, the dot product equations will not change. The first equation, the fourth equation will be the same. Both the cross product equations will change in time varying fields. This equation is varied from Faraday's law. This equation is varied from Maxwell contribution. Today, our focus is on changing this equation, which is from Faraday's law. Static electric field is conservative, moves in a straight line, but not time varying electric field. If time varying electric field moves in a straight line, can it be a part of a wave? Can it be a part of a wave? No, I am right. It can't be a part of a wave. So time varying field can't be conservative in nature. Only static field is conservative. Only for static electric field, del cross E is 0. For time varying electric field, del cross E must be not equal to 0. Because for time varying field, the field must vary with the time. And it must have orientation. If it does not have orientation or spatial variation, it can't be a part of a wave. As I told you in the previous class also, and in antennas Mahamarathon also I repeated this concept, that a wave is one which changes its phase with respect to both space and time. Here the spatial variation is 0. So it can't be a part of a wave. Therefore, if this time varying electric field is a part of a wave, then it must be rotating. It must have some rotation. Del cross E must be not equal to 0 for time varying fields. Yes, it is not equal to 0. So, by what is the value of it is determined by Faraday's law. Faraday's law will determine what is the value of this particular value of del cross E. So this is the summary of Maxwell equations for static fields, in which the first equation and fourth equation are same for both static fields and time varying fields. Second and third are going to change. Second is changed from Faraday's law, and third is changed from Maxwell contribution. These are for static fields. Let us see this equation once. For static electric and magnetic fields in an inhomogeneous source-free medium, which of the following represents the correct form of two Maxwell equations? Just now we have tabulated Maxwell equations for static fields. If I write in differential form or point form, Maxwell equations for static fields, del dot D is rho V, del cross E is 0, del cross H is J, del dot B is 0. Now if you consider source free medium, charge is 0 and current is 0. For a source free medium, del dot D is 0, rho V is 0, del cross E is 0, del cross H is 0, del dot B is 0. For inhomogeneous medium, del dot E is not equal to 0 as epsilon is varying now. Del cross D is not equal to 0. Del cross B is not equal to 0. Del dot H is not equal to 0. If you consider here, del dot E not equal to 0. Here del dot E is 0. Not this, not this. You must select between these two now. Del cross B is not equal to 0. Not this. Only left out is del cross E is 0 and del dot B is 0. Therefore, option D is the answer. Is that clear? So we'll move on to Faraday's law. According to Faraday's law, the amount of induced EMF within a closed path is equal to the rate of change of flux linkage, where lambda is the flux linkage given by n into psi m. N is number of turns. Later, Professor Heinrich Friedrich Emil Lenz said that the induced EMF will always oppose the flux produced it. Introduce the negative sign here, completing the Faraday's law now. So from Faraday's law, after Lenz's contribution, V EMF is minus d lambda by dt. As you know, lambda is n psi m. V EMF is minus n into d psi m by dt, where V EMF is V related with E as closed line integral of E dot dl is minus n into d psi m by dt. Let n is 1 for straight conductor, psi m is surface integral of B dot ds. Substituting, closed loop integral of E dot dl is equal to minus d by dt of surface integral of B dot ds. surface integral of B dot ds implies closed loop integral of E dot dl is surface integral of minus dou B by dou t dot ds. This is called Maxwell's second equation. First equation is same as static fields. Maxwell's second equation for time varying fields, and this is the integral form of Maxwell's second equation for time varying fields. Now if you apply Stokes theorem on this, closed loop integral of E dot dl is equal to, applying Stokes theorem, is surface integral of del cross E dot ds. This is surface integral of minus dou B by dou t dot ds. Removing the surface integral, del cross E is equal to minus dou B by dou t. Very clearly, del cross E is not equal to 0. Only static electric field is conservative, but not time varying electric field. In time varying electric field, orientation of electric field depends on time varying magnetic field. There will be interdependency between the spatial orientation of electric field and the time varying magnetic field. So this is the equation from Faraday's law. Del cross E is very clearly not equal to 0 for time varying fields, but it is equal to minus dou B by dou t. This is called Faraday's law. Is that clear? Okay, dear. So now we're done with changing this equation by Faraday's law. We'll try to do a numeric, which is a previous year question. Let us see what is asking now. A positive charge Q is placed at x is equal to 0. A positive charge Q is placed at x is equal to 0 between two infinite metal sheets placed at x is equal to d and at x is minus d respectively. The charge is at rest at t is equal to 0. When a voltage of plus V is applied to a plate at x is equal to minus d, and a voltage of minus V is applied to a plate at x is equal to plus d, we assume that the quantity of charge Q, this Q is very small enough that it will not perturb or disturb the field setup by metal plates. So we are assuming that this charge is small enough that it will not disturb the field that is set by the metal plates. The time that this charge Q takes to reach to the right plate is proportional to how much time it will take for this charge to reach to the right plate. This is at x is 0, this is at x is d. So to reach this right plate, it must travel a distance of d. Now velocity is distance by time. I want how much time it takes. Time is distance traveled by velocity. How much distance it has traveled, small d. So keep it as it is. By velocity. Now initially the charge is at rest. Then the charge has started moving. In these cases where initially the charge is at rest and then the charge is moving, we'll take the condition of equilibrium. According to the condition of equilibrium, the total potential energy QV or work done is equal to kinetic energy half mv square. From this V square is 2qv by m, or V is under root of 2qv by m. We can say from this velocity is proportional to under root V. Substituting, time t is proportional to d by under root V. Is not asking, it is equal to the time that the charge q takes to reach the right plate is proportional to. That's it, only proportionality. So the time is proportional to d by under root V. D by under root V, where V is the potential that is applied. This V is the potential that is applied. Option C is the answer. Is that clear? Next. A rotating conductor of 1 meter length is 1 meter, is placed in a radially outward, it is radially outward about the z-axis, magnetic flux density of 1 Tesla. B is 1 Tesla, as shown in the figure. Fine. This is given in the exam. Conductor is parallel. This conductor is parallel to and at 1 meter distance. R is 1 meter from the z-axis. It is parallel to z-axis and it is 1 meter from the z-axis. The speed of the conductor in RPM required to induce a voltage of 1 volt is. Try to consider the maximum induced voltage. Formula, what is maximum induced voltage? BLV. What is the maximum voltage I want here? 1 volt. How much B is applied? 1 Tesla. What is the length of the conductor? 1 meter. Then what will be velocity? To satisfy this condition, velocity must be 1. Therefore, from this equation, we understand that velocity is 1 meter per second. Now, for this conductor to make 1 revolution, it must cover this circumference, which is 2 pi r. But r is 1 meter here. So to make 1 revolution, to complete 1 revolution, it must cover 2 pi meter. To make 1 revolution, it must cover 2 pi meter. And the velocity is 1 meter per second. So to make 1 revolution, it will cover 2 pi meter. It will cover 2 pi meters in 2 pi seconds, because the velocity is 1 meter per second. For every 1 second, it will cover 1 meter. To cover 2 pi meter, it will take 2 pi seconds. In 1 second, it will make 1 by 2 pi revolutions. In 1 minute, multiply by 60, it will make 60 by 2 pi revolution. 5 is 3.14, 60 by 2 into 3.14, 60 by 6.28, 9.55 revolutions per minute. This is your RPM speed. Therefore, the speed of the conductor is 9.55 RPM. Is that clear? Everyone, is that clear, dear? Next, we'll go for this particular question. A circular turn of radius 1 meter. A circular turn of radius 1 meter revolves at RPM. RPM is given by N. N is 60 RPM. About the diameter aligned with the x-axis as shown in the figure, the value of mu naught standard 4 pi into 10 power minus 7 Henry per meter. If a uniform magnetic field H is equal to 4 pi into 10 power minus 7, H is 10 power 7 AZ, 10 power 7 AZ ampere per meter is applied, then find the peak value. Find the peak value. This is application of Faraday's law. Now, VEMF is equal to minus d lambda by dt. Given that it is single turn, here n is 1. Don't get confused with this end here. Here n is the RPM. N is 1. This minus d psi m by dt. Therefore, VEMF is equal to minus d psi m by dt, where psi m is surface integral of B dot ds. To evaluate this, I need B. You know, B is mu naught H, 4 pi into 10 power minus 7 into H is 10 power 7 AZ. Therefore, B is 4 pi AZ. Therefore, B is 4 pi AZ Tesla. So, B is equal to 4 pi AZ Tesla. That is what you got. Now, try to substitute here. Psi m is equal to surface integral of 4 pi AZ dot. Now, ds normally is AZ. What is the area? It must be pi r square. Therefore, psi m is, I rewrite it again. Psi m is equal to B dot S. B is 4 pi AZ dot S is pi r square AZ. Therefore, psi m is 4 pi square r square. R is given as 1 meter. Therefore, this is 4 pi square. Psi m is 4 pi square Weber. Substituting, VEMF is equal to minus d psi m by dt. How much you got psi m? Psi m we got it as 4 pi square Weber. But this flux must vary with the time. If psi m is equal to 4 pi square sin omega t Weber. You got psi m. VEMF is equal to minus d by dt of 4 pi square sin omega t. Therefore, VEMF is equal to minus 4 pi square derivative of sin omega t cos omega t into omega. V max or V peak is, this will become positive 4 pi square omega. For maximum value, cos omega t is minus 1. So you get 4 pi square omega. We know time period t is equal to 2 pi by omega. Omega is 2 pi by t. Substituting, V peak is 4 pi square omega is 2 pi by t. This is 8 pi cube by t. We know RPM is given as N, which is 60 by t. Our time taken to make one revolution is 60 by N. For example, if N is 60, RPM is 60, number of revolutions per minute is 60, the time taken to make one revolution is 60 by 60, 1 second. For example, if the RPM is 30, the time taken to complete one revolution is 60 by 30, 2 seconds. So the formula for T is 60 by N, substituting V peak is 8 pi cube by 60 by N. Given N is 60, therefore get cancelled. This is 8 pi cube, which is 248.05 volts. That's your peak induced voltage. This is your peak induced voltage. Clear? Some more practice problems are there. We'll do in the coming classes. With iconic subscription, you get 1:1 mentoring, increasing your chances of getting a top rank. You can use my code GCR10 to avail extra 10% off. This is Unacademy Combat. As many of you know, Unacademy Combat is a live quiz competition where 20 questions will be asked, 60 minutes will be given, will be conducted for mechanical, civil, electrical, EC and CSIT, where 20 questions will be curated by India's topmost faculty and 60 minutes will be given. This acts like a test of your mettle or test of your preparation, because you are trying to attempt the topmost questions. Second, there will be a All India leaderboard so that you can compare where you actually stand among your competitors. Third, we also provide you detailed video solutions of these questions so that later on you can rectify your mistakes. Fourth, and the most important, if you perform well here, you get the subscription for free. So if you're talented enough, you need not pay anything. Unacademy is coming forward to give you free subscription, and this participation in this quiz is also free. Just you can unlock this by using the code GCR10. You unlock this by using the code GCR10. So use the code GCR10 and unlock it. The combat is today, 21st of November, 11 AM. Please make a note here. As you know, for the success of or for success in any competitive exam, we need to write so many test series. Unacademy provides you such a beautiful platform where you can attempt free test series. You can use the code GCR10 to unlock it. Today, on 21st of November, there is a full-length test series, 65 questions, 180 minutes for all the branches, mechanical, civil, CSIT, electrical, EC and chemical. For all the branches, you have this. So inform your friends also to participate in this free test series. You can unlock them by using the code GCR10. This is an offer alert. If you take a 3-month subscription, you got to get 1 month subscription free. Along with this, by using code GCR10, you get an extra 10% off also. Not only that, with every 12-month subscription now, you'll get 3-month subscription. That means you can prepare up to GATE 2023. A single subscription will be useful for both 2022 and 2023 year, and the cost that you are paying is only for 1 year. So, and on this, by using the code GCR10, you get extra 10% off also. So try to utilize this. Do not waste much of the time, and use the code GCR10 and take the subscription immediately so that your long-term plan can be satisfied, or can be, you can go through the long-term plan easily. For this you can use the code GCR10. Yeah, special class features. These are the special class features that we have. We have interactive live classes, polls for the learners, you have raise hand option, and you never miss a class. You never miss a class once you on the notification. And after the class, you can download the lecture notes You can access anytime and anywhere. And this is Unacademy Ask a Doubt feature where you can ask unlimited number of doubts and get them clarified on the same platform. So you need not wander here and there to clear your doubts here. All of your doubts can be cleared at the same platform. These are the new batches. Arrow 1 GATE and ESE 2023 for GATE and ESE 2023 aspirants. For ECE Explained Bilingual started on 17th of November. Arrow 1 GATE and ESE 2023 for Electrical Explained Bilingual started on 17th of November. You can use the code GCR10 to get extra 10% off. These are the new batches for different departments which have started on 17th of November. And this is the new course modules where this particular module, Power Electronics, Power Systems and Electrical Machines will be covered, which has started on 24th of November. This is for Electrical Explained Bilingual, targeting the important concepts or important subjects of GATE 2022. Modules GATE and ESE 2022 covering the most important subjects of GATE 2022, EDC, Communications, EMTL and COA. This will also start at 24th of November. This is for ECE and Explained Bilingual. These are the new batches that are going to start from 24th of November, dear. Make a note of this. In all these things, you can use the code GCR10. You can follow me on the Unacademy app by using this link. Share among your friends so that your friends can also follow us. Thank you all, dear. Thank you all for your patient listening. Very all the best from Unacademy and the GATE Conqueror team for all your preparation. Have a very good day. Thank you all.